Hi everyone. In this video, I'm just going to go through the solution to exercise 4-8. So this question says that there is a production system with 4 serial automatic workstations, and that the first part arrives at time 0, and then exactly every 9.8 minutes thereafter. So this is a constant inter-arrival time of 9.8 minutes. Okay. And then it goes to 4 serial processes. 1, 2, 3, and 4. And then it doesn't say anything beyond that, so we exit the system. And we are told that each of these workstations is its own resource. So we want to, let's create 4 resources. And we will just assign each of these. So these are seize delay releases, each using a unique resource. And then we're given the fact that all of these workstations have a constant process time in minutes, and the process times are 8.5, 8.3, 8.6, and 8.6. And then each of these 4 resources has 2 failures, a major failure and a minor failure, a jam. So let's go to advanced process and failure, and we'll define each of these failures as given. I'm just going to do the first 2, and then I'm going to pause the video and finish the rest. So we have a major failure 1. It is of the type, it's a time, so it's based on time, and we're given that the uptime is according to an exponential distribution with a mean of 476 minutes and a downtime of uniform from 20 to 30 minutes. And then we have a corresponding minor failure with an uptime of expo 47.6 minutes and a uniform of 2 to 3 minutes. So I'm just going to pause the video now and fill out the other 6 failures. So now that we have all of our major and minor failures defined, we can go back to the Resources tab, and we can assign each of these resources 2 failures. So we have major 1 and minor 1. And major 1 uses a preempt type logic, and minor 1 uses a wait type logic. So now I'm just going to define major 2, preempt, minor 2, wait, major 3, preempt, minor 3, wait, major 4, preempt, minor 4, and wait. And then we're told that we want to keep track of the states of each of these resources. So we can go to the statistic sheet and create a new statistic. It's going to be a frequency statistic, and we're actually going to monitor the state of resource 1 for the entire replication. So we can call this statistic 1. I'm just going to use the default names in this video. So we have our frequencies, we have our states. Oops. Okay, and so now when Arena runs, it will keep track of every time the state of these resources changes and how much time each Arena spends in each of these states. So let us go ahead and run this for a single replication of 10,000 minutes. And let's put our time units in minutes as well. Okay. So now we can go ahead and run the simulation, and we'll just do things quickly so we get to the end. And we can take a look, and we see we've got our statistics for our entities, and this should always be the same because all of our times were constant. But if we go to the frequencies tab, we can see now the average time spent in each state, and then the percentage that each resource was spent in each state. So 14 minutes means that when the machine was busy, on average, it spent 14 minutes being busy before it switched to a different state. Same thing goes with the failed state and the idle state. So these are the numbers that I get. Hopefully you get something similar. And that's it for this exercise. I will see you guys all next time.